In section 8.2, which starts on page 252, we are going to be doing a couple things. One is finding the zeros of a function, which is just the x value for which y equals 0. All that means is the x-intercepts of the graph, or where our graph will cross the x-axis. We'll do this in part 2, not in this first video. The first thing that we'll be doing is graphing quadratic functions when we're now adding a c value in 8.1. We only graphed where it was a times x to the second. Now we're adding this c value. So all that's going to happen here, the graphing will be the same as what we did before. We'll still use input-output tables, but when we have something added or subtracted at the end of our quadratic functions, that's going to shift our graph either up or down depending on whether c is positive or negative. So if c is greater than 0 or positive, that's a translation up, and it just moves our parabola up however many units c is. If c is negative or less than 0, it's a translation down of that parabola. So let's see what that looks like. So on the next page, we're going to graph a few, and then we're going to compare that graph to the parent function, or f of x equals x squared. So all that means is what transformations occurred. We might have a vertical stretch or a vertical shrink, which deals with a, or we could have a reflection as well. We might also have a vertical translation, which deals with c. So the first example is x squared plus 5. So I'll use my input-output table, and then these same x values from -2 to 2, and then all we're doing is replacing x with each of these individual x values. So for when x is -2, we have -2 squared plus 5. That gives us 1. -1 squared plus 5, that is, sorry, not 1, 9. -1 squared plus 5 is 6. 0 squared plus 5 is 5. And then we should always see that since the vertex is in the middle, these two values should translate down. Well, 1 squared is 1, plus 5 is 6. 2 squared is 4, plus 5 is 9. So we need an x and a y axis. So there's our y-axis, here's our x-axis, and now we have the points -2, 9, -1, 6, 0, 5, 1, 6, and 2, 9. So here's my parabola. And then I'm thinking what transformations have occurred. Well, there's no a value, that's just a 1 in front, so there's no vertical shift, stretch, or reflection. The only thing that happened here was a vertical translation up of 5 units. If I go ahead and do the same thing for number 2, I'm using the same process, replacing x with each of these individual x values all the way down and just changing what I'm using for x based on which x I'm using. Filling in my table, then I would have 1, -2, -3, -2, and 1. So I'm going to put my x-axis right in the middle, my y-axis right down the middle. So here's my points: -2, 1, -1, -2, 0, -3, 1, -2, and 2, 3. So again, I can place my parabola right here on the graph. A is 1, so no reflection, vertical stretch, or vertical shrink. All we have in this graph is a vertical translation But this time our vertex moved from the origin down 3 units, down 3 units. I know it's down 3 units because I subtracted 3 at the end. The first one I knew it was up 5 units because I added 5 at the end of that function. A couple more here. Number 3 says our equation is negative 3x squared minus 2. So we'll go through the equation or go through using our input-output table. Negative 3 and then parentheses. First I'll do negative 2 squared minus 2. That gives me negative 14. Next one, negative 3 parentheses negative 1 in place of x squared minus 2. So negative 5. And if I continue working down, replace with 0. I get negative 2. Replace with 1. I get negative 5 again. And if I replace with 2, I should see negative 14. So negative 14 squared minus 2. Oh, sorry, I did that wrong. Negative, I'm putting in a 1 there. I got ahead of myself a little bit. This is for x is 2. So there we go. And then negative 14 again. So based on these numbers, I should have my x-axis up at the top and my y-axis again down the middle. So I have negative 2, negative 14. That's going to be somewhere well off the graph, so I won't worry about it. Negative 1, negative 5, 0, negative 2, 1, negative 5, and then the other one would be off the graph again. So there's my parabola for number 3. So I can see that it's shifted down 2. Also, this minus 2 at the end tells me, so vertical translation down 2. I can also see that my parabola is upside down because of that negative in the front. So this is a reflection. And there's one more. This is a narrow parabola. I have a 3 in front of the x squared, so that is a vertical stretch by a factor of 3. Oh, sorry. Then our final graph, give your table, your XY table a try with these same numbers, and then I'll show you what the graph looks like. So pause your video and give it a shot. So here is my table and my graph for number 4. I see that this graph is shifted down, so it's a vertical translation down 4. It is not reflected, but it is wider. So if it's wider, and if we have a number less than 1 in front of the x squared, that is a vertical shrink. All right, next check out part 2 and learn how to find the zeros of these parabolas. Thank you.